In yesterday's lesson, we were working on calculating slope. We found out that if we were given a graph, we could easily identify whether the slope was positive, negative, zero, undefined by just the appearance of the slope or the line on that graph. Now, we also found we could find the value of the slope by counting the boxes of the rise or the fall over the run, left or right. We then explored some examples where we were calculating slope if we were given 2 points on a line, and we used that slope formula. Let's do a few examples of each today to see what we remember. In this first slide, I am looking at some already graphed lines, and I've highlighted some points where the coordinates hit the intersection so that it's easy for us to calculate. Right away in the first one, we should notice that this has a negative slope. It's negative because it's falling from left to right. As I'm looking at a graph of a line that's already been graphed, I start scanning from the left and I stop and I see that as I reach this, it's going downhill. That means it's negative. The question is by what ratio? So m is equal to the change in the rise over the change in the run. This one's going down 1, 2 spaces. Remember we said negative, so I'm going to go down 2 and over 1, 2, 3. The slope here is a negative 2/3. To prove that it's true, I'm going to do it again, down 1, 2 and over 1, 2, 3. Remember that slope is constant. Looking at my second example, I already notice that this line has a positive slope. Why? Because it's rising from left to right. It starts here and goes uphill. So the question is, what's that ratio? So we're going to calculate, and we see that m is going to be positive, and we're going to count the boxes, 1, 2, 3. It's going up 3 and over 1, 2. It's a 3:2 ratio, and there's my slope. And that's all there is to counting the boxes to calculate slope when given a graph. But more importantly, and probably what we'll use more use, is the slope formula. Do recall from last time that there were 2 special other types of lines, and those were my vertical and horizontal lines. I already know this has a 0 slope because it doesn't go uphill or downhill, so m is equal to 0. And we notice that there's a constant here, so we're going to get to that in the next chapter, but I'm looking at y as being 1, 2, 3. Y is always negative 4. It's a constant, and we see that that would be the equation of that line. Here I have a vertical line, and a vertical line slope is undefined. Okay, an undefined slope. And again, its equation would be something with an x, because x is constant. 1, 2, 3, 4, 5. X is equal to 5 would be the equation of that line. Again, that's not till next chapter, but it's good to have a little heads up of what's to come. On to my slope formula. Into my slope formula, we're looking at this change in y over the change in x. Here is the formula that we want to commit to memory if it's not already there. Remember, change is a difference. So we're going to do a couple practice problems. The key to this is remembering how to set up the problem. There are 2 points. The first point is labeled x1, y1. The second point is labeled x2, y2. And in the beginning, like I said yesterday, some people label them to be sure they put the numbers in the right place. Well, my formula is over here on the right, so my y2 comes first, so that's 0 minus 6. That's my change in y over my change in x, negative 2 minus negative 4. Again, let's go ahead and simplify, and that's going to give me a negative 6. I'm going to add the opposite and get a positive 2. That gives me a negative 3 over 1, which basically simplifies to m is equal to negative 3. On to my second set of ordered pairs. m is equal to, I want you to get in the habit of writing what we're solving for. We're solving for slope, which is m. -3 minus -3 over 4 minus 12. Remember, the rule says to add the opposite, so that's going to give me 0 over -8. And we know that when 0 is in that top portion, my slope is 0. Third problem. Let's take a look at these ordered pairs. M is equal to -6 minus 3 over -2 minus 7. Add the opposite gives me -9. Add the opposite, also -9, which then gives me a slope of +1. So there is the slope formula once again. If you feel we need more practice problems, please feel free to ask. The next thing we're going to be looking at is we've already talked about finding the equation based on the slope, not the slope, I'm sorry, the x and y intercepts. The next part of this will be back to the slope-intercept form of a line. Y is equal to mx plus b. In this form, we're going to then be graphing with a quick graph method where all we need to know is the m, the slope, and the y-intercept b. And that's going to be our mission for next class.